So let me come to the point. Unsymmetrical bending means like what we have seen till now, that whenever bending is taking place, there is a symmetry is there and the symmetrical objects are there. But in case of unsymmetrical bending, such thing will not be there. And like till now what we have seen, that if bending is there, that is for eye section or beam section. But what about if it is a angle section, because that is unsymmetrical in shape. Okay, so we're going to see that how that unsymmetrical bending works. Okay, today we are going to discuss about your unsymmetrical bending. Okay, so like earlier, as I said, that if a rectangular section like this, or uh, this eye section is there, which are in symmetry. Okay, so whatever if bending takes place in such kind of structure, that will be symmetrical bending. But what about if your structural element is not in symmetry, like your C section or your channel section or your angle section? So in that case, your unsymmetrical bending will take place. So, and there is a certain difference between these types of bending. So let's see that in simple bending theory or theory of bending, the flexure formula, which is m upon I is equal to f upon y, we have assumed, and it is assumed that the neutral axis of the cross section is perpendicular to the plane of bending. Okay, and this condition applies that the loading plane or the plane of bending is coincident with the or parallel to the plane containing the principal centroidal axis of the inertia of cross section. Okay, means that the plane of loading is coinciding or with the parallel or to the parallel to the principal centroidal axis of the cross section. Okay, like if this cross section is there, if this cross section is there, so it is the plane of bend loading. This if this is the plane of loading, then that will be in the parallel or in the coincident with this centroidal axis of the cross section. Okay, but if this loading plane and that of the bending, that doesn't lie in the same plane, or you can say they are not coinciding with each other, and that contains the principal centroidal axis of the cross section. The bending is called as unsymmetrical bending. Okay, I hope this is clear to you. Let me draw something. Okay. Mm, yes. Like if a simple rectangular beam is there, and this is the these are the centroidal axis across the cross section of your beam, and if the loading which is taking place that is coinciding with this plane, as you can see in this, these are the centroidal axis and this the plane of loading, and they are coinciding with each other, if whether this load is acting from this side vertically downward or whether the load is acting horizontally. So in this case, your bending, if bending takes place, that will be symmetrical bending. But if somehow this bending is not in symmetry, okay, or this plane, this is not in symmetry, what will happen? Suppose this is your beam, and this will be your uh, centroidal axis of your beam all along the cross section, and this is a loading condition. So there is a this gap is there, so this gap is there in between this. So in such case, this we call it as if bending takes place, then we call it as a unsymmetrical bending. I hope this is clear to you all, that what is symmetrical bending and what is unsymmetrical. Unsymmetrical bending is there when your uh, centroidal axis of the along the cross section of your beam doesn't coincide with the plane of loading. Okay, then we whatever bending is taking place, we call it as unsymmetrical bending. Okay, so let's take that how to find out the centroidal principal axis of a section, or you can we can define this centroidal principal axis of a section as a pair of rectangular axis through the center of gravity of a plane area such that the product of inertia is 0. Okay, this means two axes which are orthogonal to each other. Okay, or you can say the pair of rectangular axes through the center of gravity, and the product of the inertia of this will become 0. That we call it as centroidal principal axis. Let's suppose this area is there, a random area is there, there is no defined geometry, not defined boundary. Okay, sorry, that is completely like irregular. So let UU and VV. UU means this axis and VV means this axis. These two are the principal centroidal axis. Okay, these two are, we are assuming that these are the principal centroidal axis, and XX and YY. This is XX and this one is YY. Okay, any pair of centroidal rectangular axis which is at angle alpha from UU and YY. Okay, so if we are assuming that UU and VV are the principal axis, the product of inertia should be 0. The product of inertia of these two axes should be 0. Okay, where so what we'll write? We'll write that summation of U it is visible.
Yes, sir.
Yeah, summation of U into V into delta A should be 0. What is delta A? Delta is an elementary area with coordinates U and V referred to the principal axis. Okay, if your plane of area has an axis of symmetry, then obviously it will be a principal axis. Since the axis of symmetry has to satisfy the equation summation U into V into delta A is equal to 0 about it. Okay, हमने क्या किया कि एक रैंडम एरिया लिया, उस रैंडम एरिया के अंदर ये दो एक्सिस थी यू यू वी वी एक्स एक्स और वाई वाई. ठीक है, इसके अंदर से हमने एक छोटा सा एलिमेंट, ये जो एलिमेंट है ये कंसिडर किया है और इसका एरिया कितना